Let's get ready to rumble. Hey folks, it's T2sday. We're back. This week my theme is reaching. The theme we had a couple of weeks ago, embracing failure, not that popular. I wonder why. We'll see how this one does. Reaching out in a number of ways. So first off, it's outreach. Whoops, and let's get over here. Okay. I feel like I'm doing a lot of outreach all of a sudden and beginning to get a little bit more traction on Twitter and so forth. So, right after the last T2sday update, I joined another Santa Fe Institute collective workshop on collective intelligence. I started on Wednesday, September 1st, the day after T2's update, but it actually had started on the day before, on T2sday. And, as usual with these SFI workshops, there were all kinds of interesting talks. And for me, one of the most interesting things was to get folks who have been studying more or less computational takes on human societies, stuff that's actually involving people, because certainly for the bigger picture of living computation, maybe a little bit beyond just the T2 tile project itself, that is all about understanding larger scale systems, actual living systems, as well as manufactured systems, as well as mixtures of living and manufactured systems, or mixtures of natural and manufactured systems, not sure how to say it, and how they behave and how they can be organized and how they fail and what we should be watching out for. Henry Farrell was talking about, open access versus, communication strategies that help flooding. I mean, there were lots of interesting talks. Jacob Foster was sort of a sociologist take, which was really interesting to me because it's something that I don't have as much contact with. That was very interesting. Anna Dornhaus, who I've seen a number of talks that she's done. She does all kinds of great stuff. Here she was talking about ants and how they vary in their communication strategies and what it might suggest. Look at this. Anthill in the middle, and then this whole apparatus so that the ants have to decide which path they want to take, and no matter which one they take, they're going to be going wondering about the purpose of life as they go back and forth. But the result of this is that there's this relationship between some species of ants are much more oriented towards exploiting it the best that they know right now and dominating, like Solenopsis xyloni, which is a nasty stinging ant, Starship Troopers, or at the other end, much more oriented towards discovery and flexibility. There is Dorimyrmex insanus, like the T2 tile project community. Lots of interesting stuff came out of that. In addition, This had been brewing under the hood in the background for a couple of months now, and it actually happened. Mark Hurst is a fellow that runs the Tectonic broadcast that is broadcast on WFMU out of New Jersey every week. And he interviewed me a week or so ago for the open first episode of his 5th season of the Tectonic podcast, which was yesterday. And that was great fun. And so this is his take on the T2 Tile project, right? Dave Ackley has a modest goal of re-architecting all computers. Ought to have some ambition. On the next Tectonic, Mark and Dave discuss how the dangerously outdated ideas creating today's computers, and how Dave's T2 talk about building new decentralized to save the world from big tech. And, one of my traditional problems is that I am terrified from a scientific point of view of overclaiming. And so I tend to, I don't make clickbaity titles, although I'm working on it. And I try not to get too far ahead of what the work actually shows. But it's really refreshing and helpful to see other people's takes coming back at me on this stuff. And, there was a chat, he found the original brick wall construction illustration that he used on the podcast page. And there was all this kind of chat, interesting stuff going on. I joined in, tried to chip in thoughts from here and there and so forth. It was really great. So Mark, thank you for that. And Jeff and Michael, two guys who've been sort of working behind the scenes, helping out with the project for years, at least for Jeff, got this set up, and that was just super great. So that was the Tectonic podcast, and that was yesterday, but that's not even the last thing. Then just last night, Ivan Reese, who is the current steward of the Future of Coding community, which is a podcast and all kinds of related material about trying to take a bigger view of programming and coding, which, very compatible with, again, the Hyperspace Academy stuff, the We Are Coders philosophical perspective that I'm trying to pitch in the bigger picture, where the T2 tile is gonna fit in as an implementation example. That part of the whole We Are Coders philosophy is that the way you put substance under words. You can say these things like representation and ideas and truth, and who the hell knows what they mean. Well, the point is we are now in a position that we can build machines, using regular computers or new kinds of computers, whatever, that exemplifies, well, maybe what representation means is this, maybe what an idea means is this, and we can show it. And it may have more or less to do with how the brain and the mind works, but it's an actual concrete thing that we could look at, we can poke, and we can see how it behaves independent of our conceptions of it, and that's what makes it valuable. And Ivan Reese, reached out to invite me to come talk on the Future of Coding podcast, which I would be happy to do. We talked a little bit in Twitter, and it's probably going to be in December. We'll see how that goes. News as it develops. That was yesterday. Future of Coding in December. And last week's update. Intel versus Tesla. It's done relatively well by the standards of the T2 tile project. I mean, we are seriously nerds here. One of the things that certainly was helped driven home by doing the Tectonic podcast is, regular people. Computer stuff, computer architecture, computer programming, that stuff is very, very far away from normal people, the modal person. And so it was important to figure that out and see where we were going with it. 186 views. It's number 3. See, now one of the things that's a little bit bugs me about the T2, the YouTube Studio setup is that I'm actually now competing with myself, because I'm putting up the uploaded version that's all trimmed and easier to find. But the live stream is still up there too. So there's actually like 66 views on the live stream plus 186. It's important for me to stress this. So, in fact, Intel versus Tesla would be the number one video in recent days for the T2 Tile project if we merge together the sets of views for the live stream and the, okay, whatever. But there was an interesting thing. I just sort of ran across this. There was a little pop-up hover thing that I hadn't seen before. This video is reaching a wider audience on YouTube, leading to a lower click-through rate. Wider, less, so boiling down to don't freak out about your 4.2%. Now, 4.2% didn't look that bad as far as the T2 Tile project is going, but hey, I'll take it. There have been a couple of views. The System D rant that I did, the hands-on with the BeagleBone AI, and now Intel versus Tesla are likely to be the evergreen T2sday updates. Would I rather it be the system rant and so forth? Yeah, sure, but hey, we'll take it, whatever. I mean, the bigger picture for me is it's about reaching out into the world as well as looking into the project, and we need to do both to get where the project needs to go. All right, so that's outreach. Reaching up. This is the stuff that I talked about just very briefly at the end last time. I'm going to expand on it in some detail and hopefully do a demo or so. It's what we saw in the opening video. So last week I briefly mentioned the idea of persistent transients, and the goal was to have something that's bigger than you could put into a single atom, a single site, a single cellular automata cell, to start doing higher level programming, higher level coding in some reasonable fashion. It's not just good enough to do a one-shot stunt. We need to actually build a programming environment that, excuse me, that we can code in and actually get some larger scale stuff done in. So what I did is this was the picture from last week, how to code bigger objects and so forth. And, I called it persistent transient, but number one, that's not a great name. It's an internal contradiction. I didn't like it. So there was this idea of the activated complex, the notion from chemistry where you get all the pieces together, that's the activated complex, and then the reaction happens. But activated complex, I tried using that, activated complex.ulam. It was way too big. I boiled it down to Plex. So that's the new name for persistent transient, the Plex. And a Plex, from the Greek and Latin roots, it means like weaving or braiding. Simplex means like one fold. Complex means many-fold. So we're braiding together different pieces from different atoms to make a more complex structure. That's the process of plexing. It seems okay, and it's nice and tiny. So now it's transient Plex. Once again, it's got this gather to pull together all the bits and put them in this bit storage that you use to hold them temporarily, do the event, and then scatter them back out till all the changes get recorded. Now there's a new class called Plexer, which is a base class for any atom that actually wants to participate in this plexing process. And the main method that it needs is getPlex. So we need to be able to know, given an atom, that the large scale virtual object that we're supposed to be made out of it, we need to know what class that's supposed to be. And that's what the getPlex method is designed to return. Now there's also a second method, printPlex, that I'll hopefully demonstrate for you, that's got some new magic that I'm very happy about, and it took several days to get to. So here it is, L2 plate. Again, this was all off of the level 2 plates made out of level 1 plates, which we're doing as a process of sort of maintaining, tweaking the balance between robustness and structure. At the level 1 plate, we're saying that's going to be relatively fragile and tightly coupled and relatively small, therefore. The next scale up, the level 2 plate, they're going to be more decoupled. They're going to be able to survive without having everything all there at once, because they're going to be big enough that they're going to be spreading across tiles, and tiles are going to be messing up, and we're going to need to have a more flexible coupling between the individual pieces of the L2 plate. And there it is. Now, in addition to having L2 plate base as a superclass, it also inherits from payload T and Plexer. And here it is. So, it gets very twisted. It gets kind of involved. But there are several stages, right? So we have the actual atoms. They inherit from Plexer, and they then report the type of atom, the type of virtual atom that they want to participate in. In this case, it's saying I want to participate in an L2-seq plate. I'm sorry, L2-seq Plex atom, because the goal of this first test was to get level 2 plates being able to have a sequencer, a higher level control, without tying up additional spaces inside the L2 plate border. And from there, here it is. Now we get to the L2-seq Plex itself, which inherits from Plex, because so this is the process that actually has the gather and scatter methods, and in its case, it looks, in the middle of a side of a plate. But that's not even it, right? The L2-seq Plex is the thing that gathers the bits together and then goes Shazam and makes it into the virtual object, the transition state. That is L2 plate sequencer. So we've got Plex, we've got Plexer. Now in this particular example, we've got L2-seq plate and then L2 plate sequencer. Wow. It's getting a little easier in my head. And so once you get to the actual L2 plate sequencer, it has an update function, which is a lot like an atomic individual behavior function, but it's this whole upper level. So the L2 plate sequencer looks for packet coming and going from its neighbors. It scans out, it does sensing out into the world around the L2 plate, and it checks to see if it needs to seed neighboring L2 plates. And it's beginning to work. That's what we saw in the opening video. Let's see if I can get this to work here. Okay, I didn't quite get this as automated as I want to. All right, how about that? Do we get that? Okay. So what we've got here is a seed my element, which is going to pop up and make a little 3x3 bunch of my elements, which is great. And now we're going to take the seed L2 plate. Again, this is just what we saw. There it is. Look at that. Okay. So this is all what we saw in the opening video, but now there's the one more step. Let's try this. Get an atom view window up. All right, so here, now we're just looking at some random L2 plate on the border of the thing. And, this has got all its particular details. And in particular, I think, can we now see this? Let's go over even further. There you go, maybe we can see it. Can maybe see the bits changing down here, right there. Except they're changing very slowly because there's kind of a lot going on the workstation. And this was, this is what you get. Where is the L2 plate sequencer? You can't see it. There's only one piece of it in this particular atom. But now, voila, there's a new tiny little button up here. And here's the L2 plate sequencer. Here's this distance it's got. Here's actually some little debugging output that's coming out in the middle. This is what going for the full structure of L2 plate sequencer and all that stuff actually got us. We have to write our own code to do this, but it can present, there's default code, which in fact is what this is using, that allows us to see the atoms, that the result of pulling them together in the gather, like that. And this, of course, has already, I'd say close to already paid off its costs in the... Do we have two of me on the screen? Oh dear. Well, okay, we've finished the demo anyway, so let's go back to, or let's try to go back to, all right, there we go. It still looks like two of me because, yes, folks, it is live. Okay, so that's the demo I wanted to show. Now, oops, no. Geez, now I'm all messed up. Select a scene. All right, and now, Oh yeah. Well, actually, this is another thing I wanted to show as well that I'll do real quick and then I'll finish. I actually have gotten a little bit back into the tiles, uh, um, and there is one new feature that I've been dying to dying to have for years. I'm sorry, the focus is so terrible here, but the important point is, here. Oh, actually, what the heck? Just everything's messed up today anyway. So the white here's the keymaster. I'm going to plug in an Ethernet cable, and can you see it? Not yet. Oh, there it is. I don't know if we can really see it, but right up here, there is the Ethernet address, which is something that I've been wishing for so long. Because when you plug in one of these tiles, who knows where it actually lands. So all I can say about that is I am gradually getting back into actually dealing with the tiles. Jeez, what a disaster! Why did that happen? Oh, of course, because I didn't go back over here. All right, so the insider's report. Let's call all of this last stuff the insider report. Supposed to look for a tile failed event. Didn't do that, but actually did get into it. I have started looking at the code. I got to the first place where the stuff fails when there's a timeout. I think I'm gonna, go ahead and build a packet buffer so that we can keep the outgoing packets until we actually see the next packet coming, packet coming back in the handshake sequence for a given event, and rebroadcast if necessary. Will that solve all the problems? No, it won't. There still will be bigger failures that are going to have to be dealt with. But I've started a new branch on the GitHub repo for MFM called "Don't Worry, Be Crappy," and I'm really trying to convince myself to just let it all go. Let the errors come up to visible to user level, and let's just start dealing with it. Let's just see what actually happens. All right, so that was the demo for that. All kinds of stuff happening in Ulam 5 land. I am going to save that for another day. In the spirit of, it would actually take some time to go through some of this stuff, and some, it's been 3 years since Ulam 4, something like that at least, and so a lot of these, like multiple inheritance and shared base classes, that's really been around for years, and they've really been key to all of the stuff that's been starting to work. The plates, all of this stuff absolutely depends on that structure. I mean, could it be done another way? Absolutely. But doing it this way has worked out really nice. So, as far as I know, the few folks in the world who are willing to actually play with Ulam code are all using the develop branch from GitHub. So the fact that we haven't officially released Ulam 5 is not the end of the world, but I want to get it out just to draw a line under it. And in particular, since I am making some breaking changes, I would kind of like to delay Ulam 5 even yet a little further and consider some other possible breaking changes so that maybe we could make the pain at least be finite in duration. All right, that's it. Reaching out, reaching up. We'll see how it goes. I know I'm supposed to be working on the tiles. I will continue to work on the tiles, at the very least, designing how to make the next step as far as making it more robust. But I need to pursue Plex. That is feeling, a lot of possibility. Right now, the level 2 plate is looking pretty robust, but it's not moving yet. So that would be a goal that I personally, secretly, if I'm allowed to do stuff that's still on the simulator rather than on the tiles, I want to see L2 plate moving by next time. We shall see. Hope everybody's doing okay. Thanks for stopping in again here live or checking in later. Get to see my incredible embarrassment as I flail around pushing the buttons on OBS. I feel like this is part of an arc that I'm sort of going through about learning how to be, learning how to go live. In my mind, there's always been this huge distinction between writing and speaking. And over the years, as everything's gotten recorded and zoomed and all this stuff, and since the pandemic especially, but even way before that, the distinction between what is the difference between speaking and writing, really. And I now sort of understand or believe that the difference between speaking and writing is that it's speaking if there are witnesses. It's speaking if there are folks there that could, at least in principle, interact live with you. That's what makes it speaking. And that's why conversations are sort of automatically kind of interesting in their way, as long as they're legit, as long as they're not scripted behind the scenes. So I'm going to keep on practicing doing these things live. Hopefully I'll get sort of smoother at it going forward. But, hey, it's the failures that drive the plot. It's the failures that make it drama. Thanks for coming in. I hope to see you in 2 weeks. Take care.